Hello, my dear students. Today we are going to start with the part 5 of the topic metal casting process. In this part, we will study the pattern and allowances. So, what is pattern? We have already studied about the pattern in detail in the previous parts. So, just once again, we are going to see. In casting, a pattern is a replica of the object to be cast used to prepare the cavity into which the molten material, means liquid material, will be poured during the casting process. And the pattern used in the sand casting may be made of wood, metal, plastic, or other material. It depends upon the product material. So in just we have already see in the process of making a mold. So we can see that this is the drag box, and if we are going to make only this part of the this part, this is the type of what we can say, this is the product. So in the case of product, we are going to make a pattern of the wood, and the wood is put over this drag box, and it is filled with the sand, and this sand will be and this drag box will be rotated by 180 degree, and we can see the top surface of the pattern is at the top, and this scope box is once again put over this, and the sand is filled completely. So we can see the sand is completely filled, and the pattern is there, and after ramming over there over the surface, and just take out this cope box from this surface, and we can see after removing the pattern, we can see the mold cavity is there, and this mold is ready to pour the material, liquid material, from the pouring basin. And after solidification, we can have this type of casting product, and this is the external, this is the part which is to be removed, because this sprue is also there. This sprue is a mold cavity, and this mold cavity will be filled with the molten material, and so this become the integrated part of this product, but this can be cut it down by the machining process. So now the pattern and the part to be made are not the same, and they differ in the following aspects, and we can see different points in this case. So first point is pattern is always made larger than, always made larger than the final part to be made. The excess dimension is known as the pattern allowance. This is the definition of the pattern allowance. And what is the pattern allowance? It is greater than or equal to shrinkage allowance and machining allowances. And and this is also equal to the shrinkage allowance plus machining allowances. So what is shrinkage allowance? It will take care of the contraction of the casting, which occurs as the metal cools to room temperature. We have studied about the contraction or elongation of the metals when it is when the temperature is increases or decreases. When the temperature increases, the metal will expand, and when the temperature decreases, the metal will be contract. So when the metal is in the form of liquid, that liquid will solidify. So there will be contraction, so size will be decreased. So there is a two types of the shrinkage. First is the liquid shrinkage, and second is the solid shrinkage. So there is just two types of shrinkage. So reduction in the volume when the metal changes from the liquid state to the solid state. Before solid state, there is a shrinkage in the liquid state only. So that shrinkage is known as the liquid shrinkage. And what is solid shrinkage? The solid shrinkage is reduction in the volume caused when the metal loses temperature in the solid state only. Means the temperature is at the same when the liquid metal is poured, but the material is converted into the solid, but the temperature is higher. So if the temperature is reduced up to the room temperature, the size is further decreased because of solid shrinkage. Okay, so there will be two shrinkage, liquid shrinkage and second is solid shrinkage. So now we are going to see what is shrink rule. What is shrink rule? Shrink rule is used to compensate the solid shrinkage depending on the material contraction rate. So the liquid shrinkage can be neglected and solid shrinkage must be considered. So I'm going to take an example for the cast iron, and we know that the 1 foot equals to 12 inch. So for the cast iron, there is a shrinkage, solid shrinkage of 1/8 of inch per foot of the shrink rule. What is the meaning of this? Means if we are going to make a product which will have a length of 1 feet or 1 foot, means 12 inch, so the pattern must be made 1 foot plus 1 by 8 inch. Okay, do you understand? Means the pattern must be larger than the product to be made. How much it will be larger? It will be the size of the product plus allowance. What is the allowance? 1 by 8 in per foot shrink rule. In per foot means for 12 inch, 1 by 8 inch is to be added for the dimension of the pattern. Okay, so for 12 inch it is required 1 by 8 inch. Okay, so for 4 inch it will be 1 by 24 inch for the pattern size. Okay, if we are going to make a product of 4 inch, the pattern size must be 4 inch plus 1 by 24 inch. Okay, so we can see for this gray cast iron for up to and these values are changes depending upon the product size also. So the product size, if the product size up to 2 feet, so the shrinkage allowance will be 0.125, that is 1.8. Okay, for 1 feet, 1 inch per feet, how much inch per feet? 1 by 8 inch per feet. So what is 1 by 8? It is 0.125. If the size of the product is to be required 2 feet to 4 feet, so the allowance will be changes. This is 0.105. Okay, so these are the shrink rule for the other materials also, the cast iron, aluminum and magnesium. So we are not going to learn this all the things, just you learn what is shrink rule. Okay, a shrink rule must be counted in the inch per feet, means how much inch is required to increase for the pattern in the per feet size of the product. Next point is the shrinkage allowance depends on the coefficient of thermal expansion. And this is very important point, because the thermal expansion will show how much elongation will be there for per degree centigrade change in the temperature of the solid or liquid. A simple relation indicates the higher the value of alpha, more is the shrinkage allowance. Obviously, for a dimension L, shrinkage allowance is alpha L multiplied by theta F minus theta 0. Where here the theta F is the freezing temperature and the theta 0 is the room temperature. And next is machining allowance. What is machining allowance? Means some so many times the cast product is very rough surface, so this that rough surface is required to be machined. Means there will be a further operation will be there to clean out the surfaces. So there will be an extra material is required for the material to gain a exact size of the product to be made. So this the product is to be made must be larger than the actual required size of the product. So because there will be some machining operation will be there on the product, so the size will be decreased, but we need a exact size of the product, so we need extra material. So how we can achieve this? We can achieve this by making a larger pattern, adding this machining allowance also. Okay, next is these are the allowance same as that table for the previous, that is shrinkage allowance. This there is also for the machining allowances also. The next is draft allowance. This is very important. All the surfaces parallel to the direction in the which the pattern will be removed are tapered. Why it is required to be tapered slightly inward to the facilitate safe removal. This is very important, safe removal of the pattern. This is called draft allowance. In the figure shows two patterns, one with the taper allowance. Taper allowance is also known as draft allowance. and the other without it. It can be visualized that it is very easy to draw the pattern having a taper allowance. We can see this pattern is easy to remove from this surface after solidification of the liquid metal. But in case of this without taper, if we are not providing a taper, we know the product is required to be like this only. This is the product, but we will made. So this is required for the removal of, sorry, it is not for the metal, it is the removal of the pattern only. So the pattern will be made like this. So that why it is required, because if the pattern is like straight, it will cause a defect or damage of the mold cavity. So it is very important. If damage will be, if there is a cavity or damage because of removal of the pattern, so this mold will be formed again and again to remove this damage or error in the mold cavity. So it is recommended to make a draft or tapered surface on the pattern, so that it will remove easily from this mold. So there is some example also. 10 to 25 per meter is required, means this length, this this length is measured, means if 1 meter length height is there, so we will use 10 of draft. Okay, 10 of draft. If this length is 1 meter, so this width must be 10 to 25 for the draft allowance. And it is also depends upon the material used for the mold and the pattern. So there are some table for the different material of the pattern: wood and metal, plastic. There is a different draft angle. You can use the height of the given, means this is the height and this is width of the draft. So this draft is, and there will be an angle. So this can be the tapered angle also. We can understood by this taper angle also, because this tan theta will be this height divided by this base. So both are related. So we can understood by the angle also, we can understood by the height and width of the draft. Next is the core and core prints. Cores are used to make holes, recesses, etc. in casting. So where coring is required, the provision should be made to support the core inside the mold cavity. So we have studied the what is core, and the core prints are used to serve these purposes. The chaplets are also used for the supporting the cores, and these core prints are also for the some purpose of supporting the core. The core print is an added projection on the pattern, and it is formed a seat in the it forms a seat in the mold on which the sand cores rest during the pouring of mold. The core prints must be adequate size and shape so that it can support the weight of the core during the casting operation. Okay, these are the chair or seat for the core. Distortion allowance. What is distortion allowance? This is also known as a camber. Vertical edges will be curved or distorted. This is prevented by the shaped pattern converge slightly inward, so that the casting after distortion will have its sides vertical. The distortion in casting may occur due to internal stresses. These internal stresses are caused on account of unequal cooling of different sections of the casting and hindered contraction. And prevention for that, the providing sufficient machining allowances to cover the distortion effect, providing suitable allowances on the pattern called camber or distortion allowance. Inverse reflection also, we can say that this is the distorted part and this is the cambered part. Okay, and this is original casting. If we require this original casting, and this if we don't require this is the distorted part, if we don't use the distortion allowances. And this is also cambered part, this can be also the cambered part. If we are making some type of means this is the glass. If we want this type of glass, that there can be some angle will be there. This will be the distorted part, and if this angle is in this inside, then it is known as cambered part. So we'll study the pattern material in the next part of the next video lecture. So stay tuned. Thank you.